Boom, boom, boom. Test Thursday. There are maybe 4, but I think there's 3 questions over 12.3. So let me make sure you know which ones they are, what you can do with them. You already know how to do them because it's nothing but T-scores. If you know how to do T-scores, which you should from chapter 10 and chapter 11, you're going to be pretty good. I know you will be good. Okay, so the equation of the least squares regression line, that you should know from chapter 3. This is the y-intercept, this is the slope, right? Whenever you're writing those, you should not really have y and x. You should tell me what those variables are. This is all chapter 3 stuff. This was like more review than it was from 12.3. Same with this, same with this, same with this. No, DF. No, you need to know the DF. So the degrees of freedom for slopes is n minus 2. Okay, and we discussed that on Friday. And so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. Therefore, DF must be 9. And then my question is, do you see that 9 anywhere on this piece of paper or on the printout? And you can see it right here with the DF, and it says 9. Okay with that? Yeah. I just wanted to make, because on the test you're not going to see the data. You're just only going to see this. You're only going to see this. Fair enough. So you got to know what the DF is from just looking at this. Y'all okay? So there's that DF right there. That's what it tells you. It's across from the error, and it actually says DF down there. And it's got a 10, it's got a 9, and truthfully, I don't know where all that other stuff comes from, but that 9 is what you got to make sure you know. Because again, you won't be given the data. Okay? So that DF, you need to make sure you know is 9. Where'd it go? Okay? And then you need to know how to not necessarily interpret. I hope you know how to interpret a confidence interval by now, but how to construct one for the least squares regression line, right? And you know it's the statistic plus or minus the critical value and then the standard, the standard error of the statistic, okay? So for slopes, the statistic is the slope, it's B. And that comes from your computerized printout, which is right there. Okay, that is the slope. And that's your slope of your sample, not the slope of the population. We don't ever know what the slope of the population is. That's why we do confidence intervals, right? But then the next question, the critical value, that's the big one, right? And you should know how to find the critical value because it says 95%. And so that's where you're going to use your calculator or your table or Desmos or Coach Mayer program to figure out what the critical value for a 95% confidence interval is. Typically, it's 1 point something, maybe it's 2 point something, right? If it's a Z-score, it's 1.96. T's are a little bit bigger, so it may get up to a 2. Okay? So if you're going to use your calculator for that, oh shucks, I should have turned that on first. Dang it. Come on. Or you can use your table, or you can use Desmos, right? Some of you guys are real comfortable with Desmos. So the critical value, which is different than the test statistic. Test statistic is T, critical value is T star. You're going to do one of 2 things, right? If you don't have Coach Mayer program, you're going to do distributions and you're going to do inverse T. And you can't put 0.95 because 0.95 is the middle and this only goes to the left. So 0.95 is 10.05. 0.05. 0.025. 95, sorry. 95, I did a 90. 95 is 5% left over. Half of 5 is 0.025. Okay, that's what you have to put in because calculators only go to the left. Desmos may give you the middle, I don't know. Normal gives you the middle. T doesn't. T doesn't give you the middle option. And then the DF, which we said was 9, we're going to paste it, and we're going to hit enter, and there's your t-score, and it is definitely 2.26. Okay, and this one says negative. That's okay. You got that plus and minus in front of it. So there's a positive and a negative of that, right? If you got Coach Mayer program, you can hit program and go to critical value and just run it. And its means, because it's not categorical data, it's 95%. You can do 0.95 or 95. And that's where it says n minus 1 if it's means, n minus 2 if it's slope. And so it was 9. And it gives you that same number, that 2.26. Okay? That you've got to know how to find. But you should have known how to find that from chapters 10 and 11. Okay? Critical value. Actually, chapter 10, not chapter 11. And then the next part, which is also important, so you know the statistic, that comes from B, that comes from your calculator. Then the standard error of the slope is normally the standard deviation divided by the square root of n. But in slopes, it's not. The slopes, it's already calculated for you, and that's this number right there, the standard deviation of the slope. And you don't divide it by anything, you don't do anything else. Okay, confidence interval. Statistic plus or minus the critical value, which is inverse t, whatever you got to do to find that value, and then times that, okay? I think the test just asks you what is the critical value, I think. But don't quote me on that. It may ask you for the confidence interval. Yay, good? Question about that, anything about that? So like I said, it's just right there, okay? If it wants to know the test statistic, that's given to you right here. That is the test statistic, 15. 15, wow, standard deviations away. That's going to give you a p-value of really, really, really small, which it does, like 0. And then I mentioned that I'd forgotten until I went over it. That's a two-tailed test. That 0, 0, 0 is a two-tailed test. So if it was a one-tailed test, you have to cut it in half, which that one won't matter. Because if you cut 0 in half, it's still 0. Yep. So those facts are they always two-tailed test. Always a two-tailed test. And on that worksheet, and we'll do one and just say, I'm not done. I want to go through this worksheet, the important things, right? I want to hit them. I don't want to hit chapter 3 stuff. That's important, but that's not important for this test. Hit me. This one is two-tailed. If it's a one-tailed test, you got to cut it in half. You'll know it from the ho and the ha. Okay. Correct. Not equals 2 is a two-tailed test. A greater than or less than is a one-tailed test. I do think one of them on your homework is confusing, and you're not too sure if it's one-tailed or two-tailed, but I don't think it matters if you cut it in half or not cut it in half. I think you're still rejecting both ways. I think. Again, that's on your homework. That's on your homework. Y'all okay with that so far? So I want to let's kind of make sure we clean that up. Those things you got to know for this test. Everything else on here you got to know for the AP exam, but that's not for this chapter test. Okay, that's not this chapter test. All right, so boom, boom. That was too fast. Find the residual, right? You need to know how to find residuals, but that's not for this test. But put it on there as more of a review type things, but you guys are, my students are focusing too much on that stuff rather than the stuff they need for this test. So that was a fault of mine. I should have just focused on 12.3 as opposed to linear regression stuff. Y'all okay? I thought maybe I could sneak that in as part of review, and it's too much at one time. So again, my fault. That's why I'm fixing it. So what is the equation of the least squares regression line? Again, you should know that, but you don't have to know it for this chapter test. You should know that that's, let's see, constant is the y-intercept, there's the coefficient, and there's the slope. And there's a X variables, rooms. Below is a computer output, yada, 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 for the rooms and the houses, and answer the following question. Interpret. So here's the standard deviation of the residuals. You don't need to know that for this test. Okay, that's chapter 3. Find and interpret the correlation coefficient. Chapter 3. Chapter 3. However, let's look at that really quickly. Notice that this one gives you the coefficient, the slope. It does give you the standard error. It does give you the t-value. It does not give you the p-value. And so that could be an issue on the test. I'm getting the feeling that some of you guys just don't flat care. I don't know. I mean, I got a job to do, but when y'all are not focused, it's not my issue anymore. Okay, so you got to turn this into the p-value, right? And so that's just I almost said normal CDF, it's a TCDF, okay? So TCDF, and then you got to know if it's a one-tailed or two-tailed, and you can't tell that from this question. Y'all okay? Correct. So, and that's, and again, a good question, right? This is all from chapters 9 and 10. I'm sorry. Yes, 9 and 10. Because that's a positive score, then you would go TCDF from 7.49 to 99999, right? If it was negative, you would go negative 9992 because your tail is what? Always the extremes. It's always the extremes. And then if it's two-tailed, you'll have to double it. Again, all that stuff's from chapters 10 and 11. Hopefully we have the aha moments. Chapters 10 and 11. Boom, boom, then DF, 72. 72. So I must have 74 data points. Any questions about that? Okay. Clicky, click, click. Oh, there's the DF. Oh, there's the good questions. I'm sorry. What is the p-value? Okay, there you go. What is your conclusion? So again, this is the one I was talking about that you don't know if it's one-tailed or two-tailed. Do I need to show anybody how to find that p-value? Y'all good? Can we do it? Yes. Yes, because I'll give you the ho and the ha. Okay, yeah. And the homework does that. Homework gives you the ho and the ha. And you're looking at the ha, right? Good morning, sir. Good morning, how are you? I'm great. If I was any better, I'd be twins. I'm good enough for two people. Yes, sir. I forgot what I was doing. Sorry. Now you know how my kids feel. I still love them too. Okay. Oh, enter. Enter. Don't show that. Okay. Boom, boom, TCDF, because it's a T, right? And this one was the positive. So the positive, it was 7 point. I mean, you almost don't need to do this because 7's pretty darn big. Yes. I mean, 7's pretty big. It's probably low enough. But we'll go ahead and test it just to make sure. 7 point, what was it? 49? That's what I was going to guess. Uh-oh, didn't go. 7.49. No. 70. That will almost give you the same answers if you did normal CDF, because that degrees of freedom is so big, right? As your degrees of freedom increase, your t-values decreases, and you get more and more like a z. That one probably give you the same answer. That's the p-value. Please do not put 6.83, right? We already told you it's pretty small. You guys know that, and it's times 10 to the negative 11. So if you want to put almost 0, if you double it, it's still almost 0. So it really won't matter if it's a one-tailed or two-tailed test. And so maybe that's why that question doesn't even care if it's one-tailed or two-tailed. Any question about that? So I would put p-value almost 0. I'd put almost 0. I wouldn't even put anything. They don't care what the numbers are. And then now you know what? You got to reject. There's not enough evidence. Boom, 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 boom. There is enough evidence. Okay, almost done. If it's appropriate to, so this is going off basically your decision, right? Your p-value. Here I got another computer printout. This printout does not show me the t or the p. Okay, this you need to know how to do. So we know we have the slope, and we know we have the standard deviation of the slope. We know we have the df. Everybody okay with that, right? Regression equation, interpret a slope, interpret r squared. Again, all that stuff, chapter 3. Suppose a store has this many, predict it, plug and chug. What is the critical value for 95%? So Coach Mayer program, 0.95, DF of 18. Everybody okay? You need to know how to do that for Thursday. What is the test statistic? Well, that is different than the critical value, right? Critical value is T star or little t or whatever you want to call about it. That's the test statistic. That's the big value over here, right? That's what I'm turning into the p-value. And this one doesn't give it to me. But you do know this already. You know that the test statistic is equal to the statistic minus the parameter. We've done this a bunch of times. It's on your formula sheet. Over the standard error or the standard deviation of the sampling distribution or of the statistic. Right? It's written in words on your formula sheet. You got to turn it to variables, right? Yeah. Okay. So you know what this B is because it comes from up there. This beta is what HO is, and typically we think there is no correlation, so the slope is 0. And then that is from right here. Oops, sorry, I got to move it down a little bit. Oh, that felt good. That number right there. Yay? So really, it's this divided by this gives you that t critical value, and then you're going to have to turn the t critical value into the p value. Yay? Any confusion on that? If it asks it for it. The test just asks for the test statistic. Mm-hmm. It's a multiple choice question. It's a multiple choice question. Yay? And it actually doesn't ask for the value, it just gives you the formula. Yeah, so you actually don't have to calculate anything. You just got to, which one is correct, right? One of your answers, this denominator will divide it by the square root of something because it's trying to make you divide it by the square root of n, just like we always do. Okay? Yes, sir. Say that one more time, I'm sorry. Write this with those numbers. So B is the slope, which comes from right here. Beta is what HO is. With again, HO is 0. We think there's no correlation, so there's no slope. And then HA is we think there's a positive correlation or there's a negative correlation or there is a correlation. So that's where we know if it's a one-tailed or two-tailed. If we think there's a positive correlation, we think it's greater than 0. If we think there's a negative correlation, it's less than 0. Okay? And then, so this is 0. And then we're going to put this number right here in my denominator. Yes, sir. For part D, for this, oh, part E, the inverse T. Yeah, inverse T or Desmos. You're doing the inverse of it. You got the area, you got to find the critical value for it. No. 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 Any questions about 12.3? Yes. Yes. No, definitely not. Because for linear regression stuff, it's not categorical data. Yes, it's numerical data. Now, chi-squared is categorical data, but we don't do confidence intervals for chi-squareds. Yes, ma'am. I don't want to say always, but yes. Definitely on this test. I've never seen it not 0. How about that, Paige? Okay. There may be an instance where they're saying it is known that the slope is positive. We're trying to prove it's not positive. But even then, the hoe has to be equals. So I don't think it equals a number. Okay.
How much of the exam does it?
Our test,
No.
the AP, 2 to 5%. Very, very small amount.
Yeah.
3 questions. I think it's either 3 or 4. T-value, P-value, critical value. I mean, if you can do those 3 things, you should be able to get everything else from that thing. Good? Yay? Now, let me also tell you guys, hopefully that's good enough for you, okay? And again, this is really bad of me the other day. So, I did it already. Yeah. We're 0B. 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 Classwork. Review. Yay? So there's 10 multiple choice questions off of chi-squared. There's 10 multiple choice questions off of chi-squared. And there's 6 multiple choice questions off of slope inference. And I'm not smart enough to come up with my own questions. So they came from somewhere. May have came from homework. May have came from the review on homework. May have came somewhere. AI is pretty good about making them up too. Change these numbers. Y'all okay? So 3, maybe 4, I don't remember. I thought it was 4, but now that I'm looking back and I'm thinking it maybe it's 3. But if you can define the critical value, which we should already have been able to do, the biggest difference is the DF. You got to know DF is n-2 as opposed to n-1, because if you do n-1, you will get the wrong answer, no doubt. Any other questions over 12.3? The conditions, I've never seen AP ask for those. It's on your homework, and I think there's one even on the review. I didn't put any condition things on the test. I don't know how much that tests your knowledge. I want to know that you can find the t-score, the p-value, the critical value, or the confidence interval. It's not a free response question. Yay? Good? Okay. Let me hit this button here.